In fact, the preprocessor cannot define constants or any other C language object, but it does have a feature that's commonly used for this purpose. Let's start by making a working copy of working.c out of our Chapter 4 folder in the exercise files. I'll just paste this into our working project and open it up in the editor. Now, if I come down here and use the define directive, pound define, and I'll give it a symbol 1 and a value of 1. Now, what this does is during the preprocessor stage, before anything gets past the compiler, every time it sees the text string with the capital letters ONE, it replaces that with the digit 1. And that's literally what it does. So this is not actually a constant. There's no symbol in the symbol table. It doesn't have a type. It is really just a string substitution. You'll also notice that there's no semicolon at the end of the line. This is the preprocessor. This is not C. It's actually not the C language. It's a separate language that's used by the C preprocessor, and the same C preprocessor could be used with any language and actually often is. In fact, what this is a very, very simple version of a preprocessor macro, and we'll talk about macros in more detail later in this chapter. But really what this is a very, very simple form of a macro. So if I come down here in printf, and I say the constant is, and I'll put in a %d, and we'll put a 1 over here. What will happen when the preprocessor runs through the file, it'll actually take this string, these letters O, N, and E, and it'll replace them with a literal number 1, which is a literal token. It's not actually a constant. So if I do this and go ahead and compile and run it, you'll see that we get the constant is 1. And now if I come up here and I change this and make it a string that says ONE like that and save that and run it, we'll get a syntax error because you notice the warning here. Format expects an argument of type int, but got a type character pointer. And down here we get the address of that character pointer because it's really trying to do what it can. So this is not typed. This is really just a string substitution. On the other hand, if we change this to an S in the printf and save it and run it, it works exactly as we expect. Because this is a simple text substitution, sometimes there can be unintended consequences and side effects. And so one thing that's done to mitigate that is it's very common to take all of your macro constant things like this and enclose them in parentheses. Again, in this case, it'll work just fine. And there are some cases where the macro substitution can create ambiguous syntax, and this tends to mitigate that problem. So the problems with this approach, it has no type. You can't use it with a pointer. It has no symbol in the symbol table. It's really not a constant. It's simply a text substitution. Alternatives are, instead of using a define, in many cases, you can actually use a constant variable. You can say something like const int I1 equals, and give it a 1. And now that's an actual variable. And this symbol 1 no longer exists. So if I say I1 and make this an int, now what we have is an actual constant. And it's actually part of the language and it's in the symbol table. If I go ahead and I run it, I can run it. I can create a pointer and take its address. And then I can do this. And that works. Save and run. We're getting the result that we expect. We have a little warning here that the initialization discards the constant qualifier. So this should probably be a constant integer pointer. Of course, that constant can go before or after. If I save and run, now we see that warning goes away. So this is actually strongly typed. As you saw there, we got a warning where the type was just a little bit off. Just like any variable in C. It's in allocated memory. We can take a pointer to it. It's in the symbol table, so debugging becomes easier. It cannot be used in C where a literal constant is required, as with the switch and case statement. But in C++, you actually can do that. So preprocessor macros are often used to define constants in C. It's important to realize that, in fact, they are not constants. Rather, they're simple text replacements. It's often better to use variables declared with the const keyword where that's actually possible. So now let's delete the working file and run clean to get ready for the next